Good morning, friends. Welcome to the class. How are you today? How are you today? Hand raise button. I can see Yashwant, Ramesh, Abhishek, Pulak, Taranjeet, Mehdad, and I can also see the guest one and guest two. All are welcome. Okay, good, good. Thank you very much. Very good morning. Hello, Shiva Nandini. I hope I am spelling your name correctly from Chennai. Good morning. Okay, so are we good at whatever we have learned till now? Are we okay with hands-on session which is being conducted on Sundays? Are you okay? Hand raise button. Yes, no, yes, no. Feeling good. That's cool. That's cool. Okay. Okay, fantastic. So Pulak is saying, but my installation went wrong. Yashwant, you are saying installation. Okay, that was I about to ask about the installation part. Okay, so probably my next question will be, did we install Hadoop in our machine? So this is a very crucial question. I want your all participation. Now tell me, did you get the main screen of Cloudera? No. Yes. No. Yes. No. Uh, so it is a balance out. 50% say yes, 50% say no. But I can see only 72% are voted out. So what about rest 28%? Okay. So any reason why you didn't got installed? Any technical difficulty or something else? Any technical difficulty or something else? Those who haven't installed the Hadoop, what was the problem? What was the problem? Sir, I bought new laptop yesterday. Well, congratulations, Abhishek. Which one? The Dell, Lenovo, Sony, HP. Cool. And what is the RAM of that? 8 GB RAM. Perfect. I was absent. Oh, Ramesh Babu, that's bad. You shouldn't absent. You're investing a lot of things here. You should not absent. Okay, so if you guys managed to see the post, uh, I posted few things in our Hadoop training one from the using the ID of Chaya, uh, and I have sent you the all. I'm not able to install Red Hat Linux 64. Is it fine to use 32-bit cloud startup? Hey, why are you using Red Hat Linux 64? I mean, you need not to install the Red Hat part. I sent you two links, right? Completely need to rely on that only. We did not to do any other experiment of Red Hat. Otherwise, we will be keep struggling with the environment part only. So, point I'm just repeating. Hadoop installation is the first step. Okay. So let me finish as soon as possible, and please stick to the document which we sent you. You need to download only two components. The first one is VMbox, Oracle VMbox. That is what you mentioned, and second one is Cloudera 5.5, 5.4, I guess, and link has been given to you. Don't experiment with any third thing. Am I clear? Yes or no? who haven't installed Hadoop? Yes or no? Okay, Abhishek. So Ramesh, if you are absent, if from this perspective, please download the Hadoop installation guide from the group and try each step what is mentioned there. You will be completely able to download and install Hadoop setup in your PC, machine or training wherever you are using. Sounds okay, Ramesh Babu? Ramesh Babu from Chennai, are you okay? Okay. Okay. So I there's only 14 participants. I'm strange. I mean, is the class is so demotivating or boring? I mean, people are keep producing, or maybe the cold. What is the temperature of Delhi? Abhishek, what is the temperature of Delhi? Taranjeet, around 9. Oh my God. That may be the reason people couldn't turn up. So we will wait 2 or 3 minutes more, and we will. Okay, how many guys you are keep visiting in the group? How many guys you keep visiting the group? Hadoop Training 1, yes or no? Me, Tanjir saying yes, Costa is saying yes, Aruna Panda is saying no. So please do that. Post your questions, post your weird questions, whatever you are facing the problem, because we are having the interaction only on Saturday and Sunday, and I hope you guys are keep doing from your end and you are investing some more hours from your end as well. So keep visiting the group. Okay, that's good. So I can see the 15 participants. I have one question. Can you give me on the mic? Sure. Suraj, can you take Pulak on the mic on the air? Hey Pulak, good morning.
Morning, Sandeep. Sandeep, I have
Yeah.
one question regarding the machine room lab exercises that you have given. I have copied all on the Windows file system, but in
Uh-huh.
order to do the exercise on the virtual machine, virtual box, I need to copy those things. So how do I copy into the original Oracle VM box?
Right, right. So my friend, putting is the option.
Okay.
So virtual machine is a separate machine. You cannot copy paste from one machine to another machine, right?
Mm-hmm.
So putty is the only option. You need to access your virtual machine through putty. In the last exercise, Manohar explained you in your virtual machine go and fire the command ifconfig. So you will get the
Right.
IP address of your machine, right?
Yeah.
And that IP address should be put into your putty. So that means you are accessing your VM machine through putty. Now it is your game. You can copy your paste, you can upload, you can download. Every privilege you will get through the putty, not through the virtual machine.
Okay, one more question regarding this putty. I tried to give the ifconfig server name on the putty, but putty didn't respond with the login and the password. Never
Okay.
respond. So I didn't the login ID on the putty.
So Pulak, tell me, you are using Wi-Fi or you are using a cable network?
Wi-Fi.
So my friend, do it through the cable, and while network, select adapter. Okay, I'm repeating. Uh, you have two components, VM machine and second is cloud driven, right?
Hmm.
So So in VM chain, you will go in the installation file. There is we have shown that you have a network tab and you need to select adapter option, not NAT. You need to select adapter option.
Yeah.
Okay, select adapter option and choose cable, LAN cable.
Okay. Just give me a second.
Yeah, sure.
Network, then adapter option.
Yeah.
Okay. Doesn't show anything here because it is right now not connected to any Wi-Fi or anything. So anyway, I'll try later.
Yeah, if you face a problem now, just ping me in the group or you will see the network part. There is 3 or 4 options. One is NAT, one is adapter something. So choose the adapter one and always choose the LAN option.
Okay.
Cool.
Fine. Right.
Okay. Thank you. So I think, my friend, we should start. We have around 20 participants. And I again welcome all those. Okay, that's a pretty good count. Welcome to everyone from Mumbai, from Kolkata, from Delhi. Okay. So, before I start today's session, let me travel from starting point 1. On the very first class, we have given the Hadoop introduction when we realized the big data and its importance, why the big data into the picture. Then we slowly move into how Hadoop comes into the picture. Hadoop is giving us the framework where the huge and large amount of data are being processing. Then we move into the HDFS. HDFS is something which is giving us the opportunity to store a petabyte or terabyte of data. Then we move into the MapReduce part, which is giving the opportunity to execute a huge amount of data by a certain way. When we come to the HDFS, we realize we have one very typical architecture having the name node and data node. There is some communication pattern. There is a replication factor, there is a heartbeat concept. So every node is connected to name node by some protocol. In MapReduce, which is the processing part, we realize that MapReduce is something which is taken care by mapper and reducer. Mapper is something which gets the split data. It performs an algorithm into each partition. It sort and shuffle and then it's sent to reducer part. Reducer is finally the component who aggregate your data and provide the output the way you want. Right? So this is the very high overview picture of your Hadoop, HDFS and MapReduce. Am I clear? Are we clear as of now? Yes or no? Abhishek, it is provided by Chaya. It is provided by Chaya. You can just go and ask. I want the lab recording. You will get it. Okay. So while explaining the MapReduce part, probably we have discussed about the role of job tracker and the task tracker. So listen very carefully. Okay. Whenever you submit a job saying this is my file and I want to process it, and where is the file? File is stored into your HDFS in various nodes, and the storage, location, replication, route, everything is taken care by name node. Ramesh Babu, I will sort it out. Don't worry about. Let's concentrate about today's topic. It is very important. It is very important because whatever we have discuss about Hadoop, that is older version. Okay, so now today we are talking about the latest version, and I need your complete undivided attention for today's class. So let's hang your question for next 20, 25, 30 minutes. Just put it into a notepad. When I will open the question answer window, you can go ahead with this. Sounds okay? Yes or no? Yes or no? Hand raise. Okay. Okay, that's cool. Okay, let's again try to understand the feature of your MapReduce part. So when I say MapReduce, HDFS environment, you must be very clear that we have name node which is taking the entire metadata of your cluster. The data is stored in your data node, and these all pictures you can get it from your understanding. When I talk about the MapReduce, you are thinking that there is a request from the client outside the HDFS or within the HDFS, and MapReduce is arranging itself, processing a unique way of processing and providing us the output. So when it comes to the processing part, you rely on the two components or two daemons. Daemons is a service or component within the HDFS. So you rely on two daemons, that is a job tracker and the task tracker. I'm repeating, job tracker and the task tracker. Job tracker is something, a very busy guy, okay. It takes the request from client, hey, I want a processing on file F1. So job tracker will accept this request, okay, hang out. Let me do, what can I do for you? First, job tracker will accept this request, and in the same time, if we get the other request, it will manage a queue. It will say, hang on, I'm quite busy. Your job is in queue. Let me complete the first task, then I will go into your second task. Till then, keep waiting and be cool in the queue. It picks up the first job from the queue and it will go to NAM node and it will ask, I got the request to process these data. Please tell me where are these data. MapReduce will see this metadata and it will say, boss, your data is say node 1, node 2 and node 5. Then job tracker will say, it is not sufficient for me. I need the exact location, even the location of that particular block. Name node will say, okay, I am giving you that detail. Now go whatever you want to do. The task tracker will travel to name node and it will verify, okay, not verify, it will rely on the name node that, okay, these data are stored here. So your task tracker is not able to execute that job. So say there is a salary field and you need to increase 10% salary of each employee, and those salary record are stored in your node 1, node 2 and node 5, 3 nodes. You got request to increase the 10% hike of salary. So job tracker will find a helper, a slave, a co-worker who can do this work for him. So every data node has one daemon that is called a task tracker. So every node has task tracker component also. So job tracker will coordinate with the task tracker of each node. Okay, let me give some diagramical representation for you. So my friends, say this is your name node. This is your job tracker. And outside box is your data node. And inside box is your task tracker. So what I said, these two people will keep talking. Name job tracker will ask what is the address, name node will provide this is the address. This job tracker will communicate to task tracker. And where is my task tracker? Task tracker is inside my each data node. So this job tracker will give a algorithm. Algorithm means your logic. The logic which is given by the client, the code, the script, the algorithm. So job tracker will give this logic to task tracker and will say, I am giving you two things. The first one is logic and second one is location of data. Go and execute that. This is called resource management. So job tracker is identifying the task tracker and it is assigning the task. This is a resource management. And when task tracker will execute those jobs, this job tracker will keep monitoring the execution part as well, whether this task is completely 5%, 10%, or it is completed, or it is abandoned, or it is hanged, or memory is available or not, job is started or not, data is dies or it is still alive. So those kind of monitoring is still taken care by the job tracker. And when the task tracker complete its execution part, it will return back a signal, boss, I have done your task. Job tracker will say, okay, thank you very much. Let me wait for the other output which I have assigned from this node. So this way job tracker will keep accumulating the output of task tracker from each node. And it will aggregate the all thing, it will collect the output and it will provide back to your client. So do you realize this job tracker is a very busy guy? It keeps talking to name node. It sees whether the task tracker is available or not. It sees that what is the status of your execution of task. It also sees the aggregation part. It also sees that I have 3 job requests which is placed in queue. Job 1, job 2, job 3. I need to take care of all jobs. So it is still busy in scheduling the task. So what I am saying, my friend, Suraj, I want access of notepad. So what I am saying, your task tracker, job tracker, is doing monitoring, scheduling, resourcing, so point is that whatever we are learning, that is the Hadoop 1.0. In Hadoop 1.0, we realize that job tracker is something is overexploited. Job tracker has been assigned a large number of tasks with a very small capacity unit. And what are those tasks? To monitor each and every job, to schedule all every jobs, resource management, collecting the outputs and everything. Are we clear about the responsibility of job tracker? Yes or no? Yes or no? Oh, Suraj, I wanted to go to my screen. Yeah. Okay. Good. If you understand how we are exploiting job tracker, good. My second point is, think about the name node. Okay. So your name node is, we learned that our name node is single point of failure. That means if name node is down, everything is down. And if I want a more processing, then I need to rely on very high configuration of name node. So if Facebook or Amazon or Flipkart or WhatsApp is saying, I am having the name node of RAM 1 GB, but still I'm not able to get the relevant output, relevant processing unit, then what should be our answer? Our answer is that, boss, beyond 1 GB RAM is not even available in the market. Maybe 1 GB is available, say 50 GB or 60 GB or 1 TB or something for our machine. So there is a limitation of VLSI, semiconductor. We cannot increase our RAM beyond certain points, right? So name node has a limitation. So if I want to increase the RAM of name node or processing of name node, I cannot do this. I cannot increase the vertical. Understand, vertical is something I'm increasing the RAM size. So we have a limit of vertical scalability of name node. So friends, what we are doing, we are discussing the limitation of Hadoop 1.0. So as of now, we understand two things. The first is overburdened job tracker, and second is the limitation of scalability of name node. Do you understand these two limitations? Yes or no? Andres, yes or no? Okay. So wherever there is a limitation, there are around the people who are very smart, very active in Apache, and they come up with a newer version of Hadoop. That is called Hadoop 2. Okay, before start Hadoop 2, there is one more very good point about the MapReduce. So MapReduce is a parallel processing, and when I say processing in HDFS, processing in Hadoop, it is always a MapReduce. I cannot do anything other than MapReduce. If I want to define a processing which is not similar to MapReduce, I cannot do this. And mapper and reducer, these are already defined by the programmer or a system. If I don't want to rely on that, I cannot do this. So point is that I don't have any control or tab into the MapReduce part, and everything is a MapReduce. I cannot execute a job which is not a MapReduce. So this was also a limitation of Hadoop 1.0. So as I say, with analyzing these limitations, Apache come up with the next version of Hadoop, that is called Hadoop 2.0. This is an interview question, okay, my friend. Be very sure that if someone asks you what is the difference between Hadoop 1.0 and 2.0, what is the difference between older and newer version of Hadoop, you should be able to say at least three things. The first is job tracker, second is a name node, and third is MapReduce part. Yes, Taranjeet, there is only one name node in the system. So, how Hadoop 2.0 is going to mitigate these all things, that is the agenda of today's session. Okay? So, I hope you all are very clear with limitation of Hadoop. In today's session, we will see what is MapReduce 2 and what is this term YARN. YARN looks like something it is able to overcome the limitation of Hadoop 1.0. If it is so, what is the different architecture of YARN which was not present in my HDFS or MapReduce? We will also see what is the difference between the processing of MapReduce earlier version and the next version in Hadoop 2.0. We will able to see if this happens, what is the job life cycle, how the task tracker and job tracker communicate each other. If architecture changes, everything changes, right? So what is the life cycle, how the cluster will look like, how we are going to manage that. So With the continuation of limitation of Hadoop 1.0, people say I have the other architecture, which is called a yarn. What is yarn? Yarn is yet another resource negotiator. This negotiator term is very unique. Why it is here, we will understand. And believe me, you will be very impressed with this word, negotiator. So, from this abbreviation, yet another resource navigator, we all can realize, okay, this is something related to resource part. That we have just discussed that job tracker was completely overflooded with major tasks, and resource management was one of them. So probably Yarn is going to solve that problem. Yet another resource navigator. It may have a very smart way of managing the resource. How it is happening? We will see. MapReduce 2 is something, the MapReduce which run on top of Yarn. I am repeating. MapReduce which run on top of Yarn is your MR2. How it is different? What it is do? We will see. But believe me, now MapReduce is not everything. MapReduce is only one service. I am repeating. MapReduce is not everything. If Yarn into the picture, MapReduce is only a one service. There are also other services which bring into the picture. What are those? We will see that. Also, one thing, my friend. Earlier, I told you Hadoop is good for the batch one, means write once and read many times. So that was also a limitation we cannot do with the in-stream data. So if Flipkart user are thousands of users are browsing Flipkart and we are getting the web log and we want to analyze that web log, and within a 1 second I want to send a mail. So from the HDFS and MapReduce it is not possible. Why? Because we cannot do into the in-streaming data. So believe me, Yarn is also going to solve this problem up to some extent, or it will help. It will help to execute in-streaming process. Okay, coming back to Yarn, if you see, this is our traditional architecture of Hadoop, where we have HDFS for file storage and MapReduce is for your processing part. There is nothing unique about that, right? So everything was taken care by Hadoop 1.0 through two components, two domains, HDFS and MapReduce. When we come into the Yarn part, I'm sorry, you may not be able to see the picture correctly because of some bold letter. Sometimes the slides are misaligned when we show into the projector. So kindly bear with that. You can see this list here also, this part. So if you see the new structure which is here, now Hadoop's picture is different. Now Hadoop is not looking at the previous one. We have a new components. Those new components are resource manager, application master, node manager and containers. What are these? What they are going to do? How they are going to solve the problem? We will see. Okay, so when job tracker says I'm tied up, I'm completely engaged. If your cluster is running, that 90% of tasks I'm doing. I'm also taking care of MapReduce part. I'm also taken care by storage part, scheduling part, resource management part, everything. I'm completely tired. So new version of Hadoop says, okay, let me solve your problem. You are very good in processing part. You have a very good friend, that is task tracker, and it carried the algorithm and it processed the data. So I'm assigning a job to you only to the execution of job. Forget about the resource manager, forget about the scheduling of part, forget about the monitoring of tasks. You just take care of your processing part. And what is that? This is your application master. So now Jan says, Mr. Job Tracker, this is your new task, application. Now you will be application master. You just take care of your execution part. Rest I will take care. How I will take care? I will have a one resource manager. What is resource manager? I will have one component just like a name node whose responsibility is to see which all processing unit is available, which is engaged, which is occupied, which is dead, which is available, which is not available. So resource manager is a global one in the entire node, just like name node or job tracker. So resource manager is something which take care of availability of your resource. Now it is not a job of job tracker. Application master, node manager and container. These three components are the resident of your node. So my friend, if I say, let me check if I have a diagram for you. Yes. So see, this is your job tracker and this is your task tracker. Oh, I'm so sorry. This slides explain you the limitation of MR1, which I explained you. So let me go back and I will continue my story about these four components. So, as I told you, this resource manager is something which will take care of availability of my resource. And rest three components, my friend, will be reside on your data node. Application master has only two responsibilities. The first, whether my job is started or not. What is the status of my job? What is the execution status of my job? Nothing else. So application master will responsible just to watch, monitor for the execution part. But who will execute the job? Who will execute the job? From where I will get the resource? So for that, application master need to talk to your MLA of city. Your MLA of city, and who is that? Who is your node manager? When I say node manager, it is a leader of your one node. So node manager takes care of the responsibility of I have these many resources available, and if somebody will ask me to execute the job, I have all metadata, all the storage information which need to be taken care for the execution of job. Container is something which actually execute the job. To just try to correlate with the mapper part, execution part. So if I have a logic which I need to execute, and for that execution I need a container. So in the layman language, I need a 6 container to execute the job. I need 100 container. I need only 1 container. So container is the smallest execution of your execution part. I hope I am clear. Okay, let me complete this part. Container is something which take care of execution, minimum basic unit of execution of your job. Container reports to your node manager. Container reports to your node manager. Node manager has responsibility. Okay, I have this much container, this much is occupied, this much is not occupied. So your application master, which got a request to execute this job, will talk to node manager. Mr. Node manager, I got this logic, please help me to execute that. Node manager will say, boss, you need a 50 container, but I have only 20 containers. I can give you 20 containers, but what about the rest 30? So node manager will say, okay, give me 20. I will see what I can do with the 31. So this node manager will take the algorithm and it will occupy or it will launch the container 20 container and job will start. But still application master required another 30 container. What it will do? It will go back to resource manager and it will say, boss, I executed the job but with only 20. What about the 30? Resource manager will say, wait, let me go to another node. Let me talk to another node manager and find out if I can get another container for you. Resource manager will contact to node manager of other node and it will say, I need a 30 container. Do you have that? Another node manager will say, okay, I have that. So it will pass the same logic to node manager and node manager will launch the 30 container there. So do you realize there is a negotiation between resource manager and node manager? That, okay, you got that, now I want more, I am releasing that, I am occupying that. So this type of communication is going between resource manager and your node manager. That's why it is called yet another resource negotiator. I am repeating, we have a 4 major component: resource manager, application master, node manager and container. Container is something which takes care of a smallest unit of execution. Node manager is something which is the one in each node. Application manager is something which is one in each node, but it only takes care of the algorithm and launching the container. And resource manager is one in entire cluster and it will negotiate to your all node manager. So it's time to ask you a question. So I hope the question is visible to you on your screen. Are we clear about yarn? Chinmoy, Raveli and Medard is saying no. Please put your question. Please put your question. Write only once. Write only once. I will be answering that. Resource manager negotiate directly with the node manager or does it go through the application master? No, application master is only responsible for what number of containers it required. It negotiates without application master. Sir, if resource manager can directly contact to a node manager, then why we need application master? So my friend, application master is nowhere related to resourcing part. It only takes care of the execution part. So if your logic x is equal to x plus 1, so this logic is taken care by application master. This logic will travel to your data and who will propagate that? Your application master. So application master has no idea what resources are available, what is occupied, what is not occupied, what it takes care about. This is my logic, go and execute it. I don't care about anything. That's why we call application master. Okay. Can you please repeat the component hierarchy diagrammatically once? Yes, I will explain. The next slides will going to explain more about yarn. I'm sorry, I explained here only. What does the container do actually? So container is your real labor, a real worker who will execute the job, a real mapper part who will actually execute the job. Does container also report to node manager? Yes, it reports in terms of resource availability. Yes. More questions. More questions. Okay. So now you will see a very familiar slides in subsequent pages because we have discussed lot many things here. So, okay, another question. Where does the core component reside? Uh, where does the core component reside? I didn't understand the question, my friend. Can you please explain the function of core component once again? Okay, the four component, I will explain you. No problem, Ramesh Babu. Give me some time. Give me some time. So, yeah, I do remember your question, my friend. You may want to give another explanation. I will give you, but let me go ahead. The next slide will give you the more focus, and if not, I will explain you again. Each node has application master, nodal manager, and contains. Absolutely correct. Hitesh, you are right. So container will directly interact with data node in HDFS, right? Container will data. Oh, container is inside your data nodes. Container is inside of your data nodes. So this question is irrelevant. Okay. So I hope. Okay. Now give me some break. Let me go through some other topic. And if you have a question, I will again open the question answer window. Okay. Okay, the key question is coming. Please explain again. So container will directly node has application manager. Can you okay? Please explain. I will explain. I will explain, but not now. In the subsequent slides because it is covering the same thing. So this is a limitation of your MapReduce one which I explained you. And what are those? That job tracker, resource management processing, and job, it's about 4,000 node per cluster. That means uh, if you have a job tracker, you can only add 4,000 node, not more than that. So the same thing which I explained you, the limit part of that. So if you want to add 4,001 nodes in a one main node or job tracker, you cannot do this. That was the limitation of MapReduce 1. So I also explained you there we cannot perform the real-time analysis from the Flipkart or your Amazon kind of thing because we work on the batch mode. So who has the problem of understanding of those components? Please be paying your attention here. What we discuss here is a resource manager, which is a global one, and rest three are application master, container, and node manager. Here, this slide is giving you focus about only the processing part. Okay, so if you see that there is a various slots in your yarn. So if a client request come to your resource manager or from the client, it will directly or indirectly received by application master. And application master will decide this is my algorithm, I need to execute it, and for that I need resource and I need to talk to a node manager for that. So it will go to a node manager and it will say, boss, this is a logic which I want to execute. Node manager will say, let me check what the resources I have. So you required a 5 container. I have 5 container. Go ahead and execute that. So your node manager will allocate or launch a 5 container Application master will throw its logic to a container and it will keep track the status of executions, 50%, 20%, 30%, bad, not bad, whatever, and it will collect the output from the container and application master will give back to your client. So this is only the execution part, okay? This is only the execution part. So this slide shows you now MapReduce is the only one service. If you want to execute something other than MapReduce, you can also do this through the application master. What all the other components of other services then MapReduce, that I expect answer from you. So write down the one question from my end, go Google it, discuss with your friend and come to me, what is the service other than MapReduce? What is the service other than MapReduce? Can you guys see the screen? Can you guys see the screen, yes or no? Let me have water. Okay. So after this slide, we will take a break. After this slide, there should not be any question that we did not understand the architecture of our yarn. What I told you, this is my client has expectation, this is my data and go and process it. It contact to your resource manager, which is a global, which is one, okay, this is your entire cluster and this is your one resource manager. So your client goes to resource manager and say, take this algorithm and execute that. Okay, this resource manager will go to node manager and that algorithm will be received by your application master. This application master will go to node manager and will say, see, I got a request from the client, I need to execute this algorithm. Node manager will say, okay, let me check that. Node manager will check its availability of container. It finds I have only 2 containers, but you required 4 containers. So it will say, boss, you can use my 2 containers, but now I don't have another 2. Application master will require 2 more and node manager will go again back to resource manager and say, I have a lack of 2 containers. Resource manager will see, wait, let me check if I have other one. This resource manager will talk to this node manager and it will ask, do you have the 2 containers? If you have, please give me. This node manager will see, yes, I have 2 containers. Very good. So now request is completed. But what I need to process? Where is the algorithm? So this node manager will say, go and talk to this guy, application master. So this application master, my friend, this application master is playing a big role. It is assigning a container in node 1 and node 2 also. So one application master is launching a job in a multiple containers in multiple nodes also. I'm repeating. If one master do not find the number of container, it will cross the limit of the data node and it will go to the neighbor node and will ask for the container. Now, are we clear about this? May that a very good question from you. Does that mean is resource manager a single point of failure? In other context, yes. But we have a solution for that. that I'm going to explain you. So I want more answer. Now anyone who think that still there is a communication, there is understanding gap between us in understanding of yarn object. So friends, this is a very, very unique question, a very must ask question in your interview. Okay, explain the architecture of yarn. I hope you all are clear now. Yes or no? Yes or no? Yes, sir, completely. Thank you. Very good. Absolutely. I'm happy. Key difference between MapReduce 1 and MapReduce 2 is, as I explained you, job tracker and job tasker is now no more into the existence. It is replaced by a resource manager, node manager and application manager. This is the new model where MapReduce is only a service, only one service, not other service. And now this MapReduce 2 will also execute the applications which are not MapReduce. So again, these slides will give you complete understanding of what we have been doing. So I am taking 10 minutes of break. Let's come back in 10 minutes and think about this slide. Think about this slide if you guys can able to understand this. This is a resource manager, where is node manager, where is a data node, where is the HDFS, name node, job history, if you guys able to understand this. Okay? So Suraj, let's meet after 10 minutes. Okay? Can we have a break?